Have you ever wondered how a project like Fedora Linux goes from the source code for your kernel, the GNU core utils, your desktop, your browser, and all of the random other things you might have on your system to a distro you can actually install along with all of the packages you need? Well, here we have a blog post from Superkeen, who works at Red Hat on the image builder team, along with packaging software for Fedora Linux. Obviously, different distros are going to have very different tooling and very different pipelines for how they do these individual things, but I still think it's an interesting topic nonetheless. Whilst this right now is about Fedora 45, the plan is for this to be a living document, so if things change into the future, updates will be made to it, so if you're interested about how things might change, keep this page bookmarked. Starting from the beginning, we have dist-git. Fedora stores the source definitions of every package in individual Git repositories at source.fedoraproject.org, and that has a nice little web GUI. So let's say I want to check out something like, 86box. We have the different versions for different versions of Fedora. We have the commits over here. We have the branches here. It links out to an issue tracker that is on the Red Hat Bugzilla right now. There is a pull request system. Basically, everything you'd expect there to be for just any sort of Git repo. Each repo contains an RPM spec file, any downstream patches, so if Fedora makes any local changes to an application, that's what those are going to be, and a source file that points to upstream tarbles stored in a separate look-aside cache. The large binary files stay out of the Git, the other files exist inside of Git, and thus have full version control. You can put large binaries inside of Git. There are things like git LFS, but it's not really the main function of Git. The source code is what should be in there. Packages usually interact with these repos through fedpkg, a CLI that wraps the common operations, cloning repos, uploading source tarbles, submitting builds, and creating updates. This tool is not required, but if you're commonly running the same operations over and over and over again, it makes it easier just to have a wrapper tool that does all of that for you. Also, it means you're not going to make random mistakes by just getting a command slightly wrong. The important thing about fedpkg build is what it actually does. It constructs a URL pointing at a specific commit in the Git repo and hands that to Koji, the build system. The build is fully reproducible from that commit hash. Branches map to releases, Rawhide for development. Rawhide is basically their... It's not really, but effectively rolling Fedora, F45 for Fedora 45, F43 for Fedora 43, so on and so forth. The hosting is split between Pagga, that is what we saw over here, and ForgeGo, which is the new place they are moving things to. This is eventually going to be the only place where things are being done. Building packages with Koji. It has been around since Fedora 7, and it builds essentially everything. Not just building packages, but building images and everything else Fedora needs. Koji follows a hub and spoke architecture, effectively client-server with a singular server in the center. The hub is a passive XML server that sits in front of a Postgres database. Builder daemons poll the hub for work, create a fresh mock chroot environment for each build, run the build, and upload the results. Every build starts from a clean room. Basically, there are no additional dependencies, additional random things installed. It is a clean environment to build every single time. You can never get a different result because someone installed something on the builder last week. The organizational model is built around tags. A tag is a named collection of builds. Build targets map an incoming build request to two tags, a build tag, which defines the build route, the package available during the build, and a destination tag where the finished build lands. Koji doesn't just build RPMs. Through its plugin system and content generators, it also orchestrates image builds, Kiwi images via the Kiwi build task type, image builder artifacts via image builder build, and OS tree composers via run root tasks, and those will come up later. But once a build for a new package is done, it doesn't just get automatically pushed out to the users. If that happened, there would be a lot more problems on Fedora. For that, we have Bodhi. This is Fedora's update management system. Bodhi gates releases updates through a feedback and testing cycle. A package submits an update containing one or more builds. That update goes through a sequence of states: pending, testing, stable. Users and automated tests provide karma, +1 and -1. When an update hits +3 karma, or spends enough days in testing, it will be automatically pushed to stable. The reason why this one needs to be here is there are some things out there which are kind of boring, which nobody's really paying that much attention to. If it breaks, it's not really that big of a deal. You can just push another update. But if you didn't have a system there to just, throw it out there, some things would just never get updated. If an update hits +1 karma, the maintainer can manually push to stable +2 for the critical path. What is the critical path? Well, this is documented over on the Fedora project wiki. Basically, anything that is core to Fedora being able to function. So, graphical network install, post-install booting, decrypt encrypted file systems, graphics, login, networking, getting updates, minimal build root, composing new trees, composing the live ISO, and anything else considered essential by an addition, spin, or lab. So not just the main versions of Fedora, but also for, Fedora XFCE or anything else that might be out there. Maintainers can configure part of the settings for automatic pushing of updates and karma limits. Behind the scenes, Bodhi manages all of this through Koji tags. When an update moves from testing to stable, Bodhi moves the build from F44 or F45, whichever version happens to be the latest, updates-testing tag to F44-updates tag. It then invokes Pungi, which is another thing we'll get to compose the update repository, the actual yum/DNF repo that users pull from when they run DNF upgrade. Critical path packages, the ones your system needs to boot and function, get stricter requirements. 14 days in testing instead of 7. Sometimes things get missed, so having a bit more time there for things that are absolutely critical generally is gonna catch things. Fedora isn't really that well known for just randomly breaking. It's not like it has never happened, but it is generally rare. But for Rawhide, things are a bit different. Non-critical path packages go stable immediately unless there's a gating policy. Updates can be held if they need to be, but generally it's just throw things out there as fast as possible. The whole point of Rawhide is to do testing for the stable versions of Fedora. If it's not in Rawhide, testing it for the stable version becomes considerably more annoying. Composing a release with Pungi. Pungi? There's an instrument called a Pungi. I don't know what the actual pronunciation of this is. Composing a release with, I'm going to assume based on the explanation, Pungi, but it's sometimes also said Pungi, so I don't know which one they actually go with. Doesn't really matter. Individual RPMs, even with Bodhi's gating, are just packages. Turning them into something you can download and install, an ISO, a cloud image, a repository, is the job of Pungi. Pungi is the compose orchestrator. It doesn't do much of the heavy lifting itself. Instead, it coordinates the tools that do, ensuring everything is built from the same consistent set of packages. A compose starts when Pungi Koji runs, either triggered by cron for nightly Rawhide composers or manually for milestone releases. It loads a configuration file for Fedora, that's fedora.conf, in the Pungi-Fedora repository and runs through a sequence of phases. Firstly is freezing the package set. That is, this is the set of packages that is going to be in this release, and that is done from a Koji tag. This is the package set phase, and it's critical. Every subsequent phase works from this frozen set. If someone submits a new build to Koji while the compose is running, it won't sneak into the compose, it'll go most likely into the next one. The tag-based snapshot makes the entire compose auditable. You can always determine exactly which versions of which packages ended up in any given compose. This makes it so you can actually test it and ensure when you're testing it, it is always testing the exact same set of packages. Deciding what goes where, comps, and variants. With the packages frozen, Pungi needs to figure out which packages belong in which product. This is where two XML inputs come in. For all the talk of all these fancy new data formats, so much of the world is still powered by XML. So much of the web is still powered by jQuery because why change what works? Then you have the banking industry, which relies heavily on COBOL, and, well, that's created the problem, and I'm getting side-tangented, so let's go back to the main thing. Comps. Fedora-comps defines package groups, collections of related packages like GNOME-desktop, server-product, or core. Each package in a group has a type: mandatory, default, optional, or conditional. This is the same grouping system that powers DNF group install and Anaconda's software selection screen. Variant XML defines the products in a compose. everything, server, workstation, KDE, Silverblue, and so on. Each variant lists which comp groups it includes and which architecture it supports. Most variants in modern Fedora are is empty equals true, meaning they produce only images via Kiwi Image Builder or ostree using packages from the everything variants repository. Only everything and server actually run the package gathering pipeline. So far, everything we've talked about has only been about packaging. Let's get to the images. Let's get to the ISO. Building boot images. The build install phase runs Lorax to create boot.iso, the image that boots the Anaconda installer, that is the Fedora installer. Lorax installs a minimal package set into a temporary root, compresses it into install.image, and wraps it with a bootloader into an ISO. One Lorax task runs per variant architecture combination, typically in a Koji run root environment for isolation. Again, that's you have a clean environment to build it in, so you have a consistent, reproducible result. The resulting boot.iso is the foundation for installer ISOs. It doesn't contain the packages themselves. Those get laid on top in the next step to produce a dvd.iso. The create ISO phase takes the boot ISO from build install, overlays packages and repository metadata on top of it using XOR-ISO, and produces the final installer ISOs. For Fedora's production compose, this means primarily the server dvd.iso. Most other variants get their media from Kiwi or Image Builder instead. Whilst it is called dvd.iso, it's the same ISO you're using on a USB, on any other install medium. The DVD naming is likely just a holdover from, when people actually used CDs and DVDs to install operating systems. Building images with Kiwi. Kiwi is the primary image building tool in Fedora's Compose. It builds cloud images, AWS, Azure, GCP generic, Vagrant boxes, container-based images, WSL images, and live ISOs for most desktop spins. Kiwi was originally created at SUSE around 2005 and is a two-step builder. Prepare a root file system by installing packages, then package it into the target format. Image definitions are XML files, validated against a RelaxNG schema. Kiwi integrates with Koji through a built-in plugin providing the Kiwi build task type. The parent task checks out the image description from SCM, parses the XML, and spawns one subtask per architecture. Each subtask creates a mock build root, replaces all repository definitions in the XML with Koji-controlled repos, so the build uses the composer's frozen package set, runs kiwi-ng system build, and uploads the results. Building images with Image Builder. Image Builder handles the ostree-based and bootc-based artifacts, Atomic Desktop ISO, Fedora IoT, Fedora Minimal, and boot.iso, basically your immutable artifacts. Under the hood, Image Builder is built on top of OS Build, a pipeline-based build engine that processes JSON manifests. Each manifest describes a cyclic graph of pipelines, and each pipeline runs sequential stages, small executables that do one thing: install packages, configure a bootloader, create a partition table, embed an ostree commit. There are currently 176 stages. Stages run in bubble-wrap sandbox environments with file system and network isolation. The Image Builder CLI is stateless, so it doesn't retain any state. It reads distribution definitions, resolves package dependencies, generates an OS build manifest, and runs OS build directly. The Image Builder CLI is stateless. It doesn't remember anything that is happening. It just does the thing and then goes to the next thing. It reads distribution definitions, resolves package dependencies, generates an OS build manifest, and runs OS build directly. And of course, there is a Koji plugin for it as well. As was mentioned just before, Atomic Desktops are part of this pipeline as well. Fedora Silverblue, Kinewhite, Sway Atomic, Budgie Atomic, and Cosmic Atomic are all built differently from traditional package-based variants. Instead of shipping a pile of RPMs for the user to install, these variants ship a versioned checksum file system, an ostree commit that the client replicates automatically. rpm-ostree is the tool that makes this work. It's a hybrid image/package system combining libostree, atomic ostree deployment, with RPM, the package management via libdnf. On the compose side, rpm-ostree compose tree takes a tree file, a YAML specification listing packages, configuration, and post-processing scripts, and a set of RPM repositories, and produces an ostree commit. Pungi's ostree phase invokes this command in a Koji run root environment for each Atomic Desktop variant. management. The tree files live here in the workstation OS tree config repository. They use a layered include system. Silvertree OS tree YAML includes Silverblue common YAML, which includes common YAML. So it lets you have these abstracted away core sets that everything else needs to have, which conditionally includes fedora.yaml and architecture-specific files. The compsync.py script bridges the gap between comps groups and tree file package list. It parses the comps XML, extracts the default and mandatory packages from groups like GNOME Desktop and Workstation Product, and writes them into generated YAML files. This way, the desktop environment packages stay in sync with what comp defines, while the tree file adds OS tree-specific packages, boot upd, compose FS, and applies exclusions for packages that are flat-packed or incompatible with OS tree. Every single compose produces a set of metadata files that describe what is in it. A compose info.json, this is release identity, variant definitions, and file system paths. Images.json, every image with its type, format, checksums, and size. RPMs.json, every RPM organized by variant and architecture, and .treeinfo, per variant metadata consumed by Anaconda to find installation trees. Pungi creates these as it goes. At the start, it generates a compose ID. Each image producing phase adds image objects. The gather phase populates the RPM manifest. At finalization, everything gets written out. Downstream consumers rely on these files heavily. Anaconda reads the .treeinfo to discover where to find packages and boot images during installation. Bodhi inspects compose metadata for update management. openQA reads images.json to locate images for testing. Mirror management tools query the metadata to decide what to sync. Once a compose is done, then it is time for automated testing with openQA. This was originally developed by SUSE and adopted for Fedora by Adam Williamson and the Fedora QA team. openQA boots the compose images in virtual machines and runs through test scenarios. Installation workflows, interactive, kickstart, various disk layouts, desktop functionality, upgrade paths, and basic system validation. Tests are written as a combination of test script, needles for visual matching, and Perl test module for interaction, and maintained in the OS auto-inst distro Fedora repository. If you want to check that one out, that was linked right here as... I don't know why their ForgeDo keeps doing this. Let's do a refresh. Who knows? Every nightly rawhide compose and every milestone compose, beta, final, triggers an openQA run. Results feed into the release validation process, and blocking bugs found by openQA can hold a release. The system also tests update composes from Bodhi, catching regressions before they reach users. So this is what the entire chain looks like, written out as a set of steps, I guess. If you like charts, there is your chart. Major modifications to Fedora, whether new tools, default changes, or mass rebuilds, go through the changes process. This is the governance mechanism that tracks proposals like use Kiwi for cloud images, or switch boot to ISO to image builder, or ones I've covered in the past like switch to Wayland by default, or make Fedora KDE an addition rather than just a spin. Changes come in two flavors. System-wide changes affect critical path packages or system defaults and need detailed proposals, contingency plans, test plans, and FESCO approval. Self-contained changes are scoped to packages the proposer owns and get lighter review, but still need FESCO approval. The lifecycle is draft a wiki page, submit it, get reviewed by the change wrangler, get voted on by FESCO, the 9-member elected engineering steering committee, implement a rawhide, and meet completion checkpoints tied to release schedule. If a change doesn't meet completion checkpoints, it usually gets deferred to the next Fedora release. This was a really dense one, and that is a lot to take in, so if you're actually curious about the topic, I'd recommend going back through the document, trying to understand what is going on, and I don't know, maybe get involved in the Fedora project if that is something that you want to do. So, that's going to be it for me. If you like the video, let me know your thoughts down below. Go like the video. Go subscribe as well. Go hype the video if you're on mobile. And if you want to become one of these amazing people over here, check out the Patreon subscribes Daily Bearer Pay, linked in the description down below. That's going to be it for me, and that's a cool hat.